All right, so let's go and look at problem number 10. Here we go. We start off with how many congruent sectors has the spinner been broken into? So we need to count up all of our equally sized sectors here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 congruent sectors. Find the area of the entire spinner. What shape is this spinner? It is a circle, and so to find the area of the circle, we do pi r squared. That is an area formula that you need to know. What is the radius of this particular spinner? 33. So the area is equal to pi times 33 squared. And then we need to grab our calculators at that point. When you pop this into the calculator, you get approximately 3,421.194. And do we need to put units with that? Centimeters squared, yes. Squared units because we have found area. Find the area of one sector. So to find the area of a sector, we have area is equal to fraction times pi r squared. So same thing as when we found the area of the entire spinner, except I'm not looking for the entire thing. I just want one of those sectors. So I need to figure out the fraction of the circle that I'm looking at. We said this whole circle was broken into how many? 12 sectors, and we want how many out of those 12? So what should my fraction be? 1 over 12. So 1 over 12 times pi times r squared, and my radius is still 33. So 1/12 times pi times 33 squared. When we put that into our calculator, we get an area of approximately 285.1 centimeters squared. Yes. Absolutely not. No, that changes your fraction entirely. That's saying you have 12 circles that are this size. The 1 over 12 tells you that you have 1 out of the 12 pieces that it's been cut into. When you flip the fraction over the other way, it does very much so change the meaning. Very good question. Yes, Sylvia?
I was just going to ask for B, you know where it says 0.194?
Mm-hmm.
What gives it actual 0.2?
If you had it to 0.2. So the directions say we need to round it to the nearest hundredth, which would be 2 decimal places. So you could have 0.19 instead of 0.194, but you wouldn't want to round it just to 1 decimal place. That would be to the nearest tenth. So if the directions say to the nearest tenth, then 1 decimal place is okay. Nearest hundredth, you need 2. Nearest thousandth, you need 3. All right, good questions today. All right, last part of this question, find the area of 7 sectors. How is that going to change from what I just did in the above part C, where I just found the area of 1 sector? Fraction's going to change. How will my fraction change? What'd you say? 7 over 12, absolutely. Fraction times pi r squared. We want 7 out of the 12 sectors, so the fraction is 7 over 12 times pi times 33 squared. And when you do 7 over 12 times pi times 33 squared, you get 1,995.697 centimeters squared. So Sylvia, to add to my answer to your question from before on this one, if you were going to round it just to 2 decimal places like the directions say you can, that 7, which is in the 3rd decimal place, would cause the 9 to round up. That would round that up to a 10, which means I would have 1,995.70 technically. If you just write it as 0.7, if that next digit is a 0, that's totally fine. But that's why sometimes when it says to the nearest hundredth or even to the nearest thousandth, we might only have just the 1 decimal place because that 3rd or 4th number would cause the others to round up. And if they're 9s, then they're going to bump over to 10s. All right. Nice one to start off on. What else do we want to see off this review? Number 3? Absolutely. Let's go look at number 3. Number 3 says, using the measurements given in the pictures, find the perimeter and area. You must show work. So on part A and on part B, they've given me a measurement down here, and they've given me a measurement here. So this one would be the length of one side. And the dashed one in this picture, right here, that we have labeled as 23, is that a radius or is that the apothem? That's the apothem. How do we know by looking at it that it's the apothem and not a radius? It makes a right angle when it hits the side, yes. A radius doesn't go to the side, it goes to a corner. So if it goes from the center to a corner, we have a radius. Center to the side, making a right angle, is the apothem. So first thing we're going to find is the perimeter. Perimeter is equal to the number of sides times the length of one side. How many sides does this first figure have here in part A? 7 sides. And each side is 22.15 units long. So we're going to take 7 times 22.15. And that gives us a perimeter of 155.05. No need to put units with that because they did not give us any units in the problem. And then the area for a regular polygon, this is a regular polygon, is 1/2 times the apothem times the perimeter. So I have 1/2, and then the apothem here was a length of 23, and the perimeter that we just found was 155.05. And then we take that and put it into the calculator. We get an area of approximately 1,783.075 units squared. Part B, we're going to do the exact same way because once again, they have given us the apothem and a side length. They didn't show the right angle marking, but it does go from the center to a side. And it appears to be making a right angle marking. Normally, we cannot assume that. But in this case, we are okay to call this the apothem. And then we have the length of one side. So to find my perimeter, number of sides times the length of one side. How many sides do we have on this one? 8 sides. And each side is how big? 10 inches. Giving us a perimeter of how much? 80, absolutely. We have a perimeter of 80 inches here. Not inches squared because it is not area that we found. And then the area, 1/2 apothem times perimeter. How big is our apothem this time? 12.1. So 1/2 times 12.1 times 80. And that gives us an area of approximately 484 inches squared. What else would you guys like to see from the review? Yes. 14C? Absolutely. Yes. Yes, you may. 14C, this is a really good one. So we have two different shapes here. We're supposed to find the area of the shaded region. What two shapes do we have? Circle and a square. Are we going to be adding, subtracting, or a little of both? If I want to find the area of the shaded region, subtracting. We're going to do the area of the circle minus the area of the square. Area of the circle, my formula for that is pi r squared. So I'm going to need the radius. The only thing I have so far is the length of one side of this square. So I know down here would also be 12. In order to find the radius of this circle, I'm going to have to find the diameter, which is this diagonal of the square. Because these two segments will be congruent. This will be a radius and this will be a radius, with the entire diagonal being my diameter. What do we know about the corners of squares? They are 90-degree angles. So what kind of square do I have right here? Or sorry, triangle. Thank you for correcting me. What kind of triangle do I have? I have a right triangle. What can I use to find missing sides on right triangles? Pythagorean theorem. A squared plus b squared equals c squared. C has to be the hypotenuse. What do I put in for the hypotenuse? I can put d for diameter. We can leave it as c. We could call it x. That's the unknown thing that we're looking for in this problem, because what I want is opposite that right angle. So I'm going to go ahead and call it d for my diameter. So what do I put in for a and for b? 12 squared, 12 squared. How much is 12 squared? 144. So I have 144 plus another 144 equals d squared. 144 plus 144 is 288. So 288 equals d squared. What next? We're going to square root both sides. I'm going to go ahead and change this into its decimal form. The calculator would give me a radical form of 12 square root of 2, which is fine, but we're going to have to take our answer and cut it in half to get the radius. So I'm going to go ahead and change it into decimal form right here. When we do the square root of 288 in the calculator, you get approximately 16.971. And so then the radius is equal to the diameter divided by 2. So 16.971 divided by 2, which comes out to be approximately 8.486. So this is what we're going to use in the place of r right here. So area of my circle is equal to pi times 8.486 squared. Now I can grab my calculator and type that in. For the area of the circle, we have approximately 226.233. What'd you say? So only the units would get squared, and since we don't have units on this problem, I wouldn't square anything. Or you could write units squared next to it, that would be okay. But the number itself does not get squared, it's the units that get squared there. So let me go ahead and write that in. But I like that you were on the lookout for that because of area, that's fantastic. All right, now we need to find the area of the square so that we can subtract that. How do we find the area for a square? What'd you say? 12 times 12. We take the length of the side and we square it. So I have 12 squared, which we already know from up above is how much? 144, and that would be units squared. So 226.233 minus 144 gives me an area of approximately 82.233 units squared. Fantastic. What else would you guys like to see? Number 11? Absolutely. Number 11, we need to identify these different pieces, and then for 4 of them, we need to find the measurement. So first thing they want is a radius. There are 2 different possible correct answers here. Remember, a radius goes from the center to a corner. So AG would be a radius. Or what's the other segment that goes from the center to a corner? BG. So AG or BG for my radius. An apothem goes from the center to the side, and it makes a right angle where it hits the side. And again, it needs to hit the side of our polygon, our straight-sided figure, not the circle. So what would be the apothem here? GH or HG. Nicely done. Minor arc. We're going to go between 2 vertices here. So we could have AB, or you could have BC, or CD, or DE. All of those would be minor arcs. Remember, when we're indicating an arc, you need that arc or that curve over the letters. Minor arc, we only need 2 letters. To find the measure of that minor arc, we're going to take 360 degrees. We're going to divide it by however many sides my polygon has, however many chords there are in this circle. So we've got 1, 2, 3, 4, 5, 6 chords, 6 sides to my polygon. 360 degrees divided by 6 gives me 60. So the measure of my minor arc is 60 degrees. Major arc. We're going to do the entire circle except for that minor arc. So A, and then I'm going to go this direction around to B over here. So I need 3 letters. So AFB, or AEB, or ADB. The middle letter needs to indicate where I go after point A. My first and last letters need to be the ends of my arc. And the measure of that major arc is going to be 360 degrees minus the measure of the minor arc. So since my minor arc was 60 degrees, we do 360 minus 60, which gives me a major arc of 300 degrees. Central angle, there's only one central angle that's been drawn in the picture. Goes from a radius to the center to another radius, so AGB or BGA. The measure of the central angle has the exact same measure as the minor arc that we did earlier. 360 degrees divided by the number of sides in my figure, which is 360. So we have a central angle of 60 degrees. An inscribed angle needs to have its vertex on the circle. So my inscribed angle could be BAG. Its vertex is on the circle here. We want to find the measure of that angle. So I'm going to look at this triangle right here, because I know that this is a right angle, and a right angle is how many degrees? 90 degrees. I know that my entire central angle here is 60 degrees, and what is the apothem doing to that central angle? It's cutting it in half. So when I'm looking at this, I'm going to kind of redraw this triangle off to the side. So here's the apothem. Here's the radius. And here's part of the side, half the side of that polygon that's been drawn in there. Here's my 90-degree angle. You said it's going to cut this central angle in half. So how big is this angle? 30 degrees. And here's A. So if I want to find the measurement of this angle right here, I'm going to do 180 minus, and then I'm going to add those other two angles together, the 90-degree angle and the 30-degree angle. So I would have 180 minus 120. What is 180 minus 120? 60. Now, one thing I want to point out. This is a coincidence that we have three answers that are all 60 degrees. It is not typical that the measure of my inscribed angle is going to be the same as the measure of my central angle. That's because we specifically had a hexagon here. If I had a heptagon or a pentagon or an octagon, we would not see the central angle and the inscribed angle being the same size. The minor arc and the central angle are going to be the same size. But the central angle and the inscribed angle are typically not the same size. All right, last thing they wanted me to do, write a congruence statement for the two congruent triangles pictured in the figure. What are they talking about? Two congruent triangles? Where do you see two congruent triangles? Yeah, this one that I have highlighted in yellow, so AHG or AGH. And then this one on the top side, BGH or BHG. When I write my congruence statement, I have to make sure to match up corresponding congruent parts. So in that yellow triangle, give me one way to write the yellow triangle. You said HGA? That's the one that I heard first, so let's go with it. Triangle HGA is congruent to triangle. This angle H on the highlighted yellow triangle would be congruent to what angle on that top not highlighted triangle? H. 90 degrees on the bottom, 90 degrees on the top, because it makes a straight line there. So H goes first. And then angle G on this yellow triangle, which is 30 degrees, would be congruent to what angle on the top not highlighted triangle? G. And so what would have to come last? B. HGA is congruent to HGB. So I know that angle A right here is the same size as angle B, because the other two angles of the larger triangle that's pictured there that's being bisected by the apothem would be congruent. All right. What else would you guys like to see from the review? We have about 17 minutes left. That's probably enough time for 3 more problems depending on their length. Number 1? Absolutely. Let's go look at problem number 1. We have 3 different shapes here. You guys need to know the area formulas for all 3 of these shapes. These are formulas that I will not give you on the test. So what's this first shape that we have here? Trapezoid. It reminds me a lot of a triangle. What's the formula for a triangle that we know from a long time ago? 1/2 base times height. My trapezoid is very similar, 1/2. We have 2 bases, so we have to add those together. Base 1 plus base 2, and then we still multiply it by the height. So area equals 1/2 height times base 1 plus base 2. Looking at my picture, I know that this right here is congruent to this space here, so this would be 3 centimeters. The top up here, that's my base 1. The bottom, I have to add all those together. What do I get if I add 2.5 plus 3 plus 2.5? 8. So this is 8 centimeters. So I can go ahead and substitute in for both of my bases here. Area is equal to 1/2. I don't have anything to put in for the height yet, but for my bases, I have 3 plus 8. The height has to form a right angle with the bases. So this dashed line here is my height. And I don't know how big that is. But what do I have to work with right here? I have a right triangle. And what can I use to find missing sides on a right triangle? Pythagorean theorem. So I'm going to do that down at the bottom here. A squared plus b squared equals c squared. C has to be my hypotenuse. How big is C here? 6.5. That is opposite my right angle, so it has to be my hypotenuse. What goes in for A and for B? Yes, 2.5 and H. So now I need to grab my calculator and start squaring some pieces. I have H squared plus 2.5 squared comes out to be 6.25. And 6.5 squared comes out to be 42.25. So then I subtract 6.25 from both sides. What is 42.25 minus 6.5? Or sorry, 6.25. $42.25 minus 6.25. How much? Super close. 36. And then we square root both sides to get h all by itself. What is the square root of 36? 6. So my height is 6. That's what we're going to put in for h up here. And now I can take that and pop that all into my calculator. I get an area of 33 centimeters squared. For part B, what kind of a shape do I have here? A rhombus or a kite. This one happens to be a rhombus. I know that because both of the diagonals are bisecting each other. A kite, only one of my diagonals is being bisected, but I use the same area formula for both of those. Area formula for a rhombus or a kite is 1/2 diagonal 1 times diagonal 2. Well, I know that this part right here is 24 inches. So how big is this? 24 inches. So how big is my diagonal 1 then? 48. So that's what I'm going to put in for one of my diagonals. 1/2 times 48. What about my other diagonal? This much is 36. So how much is this? Also 36. So how big is my other diagonal? 72. 2 times 36 is 72. So 1/2 times 48 times 72, and then I pop that into my calculator. I get an area of 1,728, and our units on that would be inches squared. Last shape here on part A. What do we call that shape? Sorry, not part A, on number 1. What do we call the shape here in part C? A parallelogram. How do we find the area of a parallelogram? What is the area formula for a parallelogram? Nope, that's for a regular polygon. We have a 4-sided shape here, so we have a quadrilateral. Area is equal to base times height. Do we know how big either of those are, the base or the height? Which one do we know? We know the base. How big is the base? 20 inches. Here's my base. So area is equal to 20 times my height. I don't have that yet. That is what is being represented by this dashed line right here. Has to make a right angle with my opposite side. Remember, the height and the base always have to form a right angle, or else you don't have a base and a height that go together in a formula. What kind of a shape do I have to help me figure this out? A right triangle. So once again, Pythagorean theorem, a squared plus b squared equals c squared. What goes in for c? 24. Or sorry, 25. My apologies. I heard that wrong. What about for a and for b? 7 and h. So 7 squared plus h squared. 7 squared is 49. So 49 plus h squared equals, what is 25 squared? 625. Then we subtract 49 from both sides. That gives me h squared is equal to 576. And then I square root both sides. And the square root of 576 comes out to be how much? Square root of 576. Grab a calculator if you need to. Let me see. Yep, 576. I was gonna say that seems a little small to me. 24. So our height is 24. So we do area is equal to 20 times 24, which comes out to be 480. We have a unit of inches in the picture, so this would be inches squared since we're finding area. All right, we have 7 minutes left, which is enough time for one more problem, unless it's really, really short. What else would you guys like to see? Number 2? Absolutely. A trapezoid has one base of 15 inches, a height of 14 inches, and an area of 182 square inches. Find the length of the second base. So we need to know our trapezoid area formula. Area formula for a trapezoid is very similar to a triangle. 1/2. I have two bases, base 1 plus base 2, and then we have our height. They told me that the area is 182, so I put that in for A. So 182 equals 1/2. We know that the height is 14, so I'm going to put that in for H. And we know that one of the bases is 15, so I'm going to put that in for base 1. I could put it in for base 2. It doesn't really matter. You decide which base you're going to put this in for. And now we need to work backwards to solve this for base 2. So the first thing I'm going to do is get rid of this fraction. How do I get rid of a fraction of 1/2? Multiply both sides by 2. So my fraction goes away. 182 times 2 gives me 364. So I have 364 equals 14 times 15 plus B2. At this point right here, you can distribute. That is mathematically valid. It's going to take you an extra step to solve the problem if you distribute right here, though. What operation is connecting the 14 to the 15 plus B2? Multiplication. And how do I make multiplication cancel? With division. I'm going to divide both sides by 14 so that I can get rid of that. 364 divided by 14 gives me 26. So I have 26 equals 15 plus base 2. I don't need the parentheses around the 15 plus base 2 anymore because there's nothing else on that side of the equation anymore. So then I'm going to subtract 15 from both sides. And what is 26 minus 15? 11. What kind of units should we put with that 11? Inches. So 11 inches is how big base 2 is. We still have 4 more minutes, so I have enough time for one other short one if you guys want to see another one. Number 4. Let's go see if we have time to do it. I believe we do. I don't know if I'll have time to do the whole thing, but I'm sure I will have this completely in another class. I'm going to go through as much as I can until that announcement bell goes off. All right, so we have a radius of 6.8 inches that they give me right here. So I'm going to draw that in. A radius goes from the center to a corner. So I'm actually going to go ahead and draw in 2 radii here so that I've made a little triangle. This is 6.8 inches. This is 6.8 inches. They want us to find the area. This is a regular polygon, so I'm going to need the apothem and the perimeter. If I'm going to find the apothem, which is going to bisect this angle in this side here, making a right angle with my side, I'm going to need to use right triangle trigonometry, and I'm going to need to figure out the size of that central angle. So I'm going to redraw that triangle here off to the side. So here's my radius and my apothem. And then this guy down here is half the side of this figure. right, central angle. That would be this whole angle right here. Measurement of the central angle is equal to 360 degrees divided by the number of sides we have. How many sides does this figure have? 9. 360 divided by 9 is 40. So this central angle here is 40 degrees. I have drawn just half of that over here. So we would have a 20-degree angle up at the top. Absolutely correct. That would be 40 divided by 2, which gives me a 20-degree angle. We're going to stand up at this 20-degree angle, and we're going to label our sides. 6.8, my radius is my hypotenuse. The half side is my opposite side, and the apothem is my adjacent side. So I need to use the hypotenuse because I have that. And I want to find the apothem. So if I'm thinking SOHCAHTOA, the one that lets me use adjacent and hypotenuse is cosine. So I would have cosine of 20 degrees is equal to my adjacent side, which is my apothem, over my opposite side, which is 6.8 inches. Then I would multiply both sides by 6.8. 6.8 times the cosine of 20 degrees comes out to be about 6.39 inches for my apothem. So I need that. We did just run out of time, but I would need to find this half side here. So I would need to use the hypotenuse and the opposite, which means sine, to find half my side, times it by 2 to find my whole side, and then I would times that by 9 to find the perimeter, the length of one side times the number of sides, and then I would have all the pieces that I need. Answer key for this is already up in Canvas. If you go to today's page, you scroll all the way to the bottom, you'll be able to find the answer key. I will also be posting videos of every single class period today. So if you want to see the remainder of this problem, I'm sure it will be asked about in a different class today. You can watch those other videos for any problems that we did not get to today.